Welcome. In this video, I just want to demonstrate how we can come up with a generic class and a generic generic interface. We are going to start by looking at non-generic form of the same. We are going to use the stack. We want to come up with a program that should be able to do some stack operations. So, as you can see from this page, we have an interface of stack, and this interface of stack has got four methods. The two which are always there, we have push and pop. Push will be used to insert a new element into our stack, and pop is used to remove and read the last element or the top element in our stack. And we have these other two which we've included. First one, checking whether our stack is empty, and the last one, checking if our stack is actually full. So this is our interface, non-generic, and we would like to check how this interface is being actually implemented in the stack array class. So we have created a stack array class here, which is implementing the stack interface. Take note of this. We are implementing stack interface, and we have the first member as size, which will be keeping the number of elements that have been inserted in our stack. And we have capacity. The capacity is just used to, when we are creating our stack object, it's used to actually specify the maximum number of elements that can be added into that stack. So we have capacity. Then we have the array of objects. So these are actual arrays that we are going to be entering. In our case, we are using an array as a structure for implementing our stack. Our stack interface can be implemented using different structures. You can use maybe a linked list, you can use another structure, but in this case we are going to implement it using an array. So our array will be of type objects. So we are going to be using that as our container, where we are going to be pushing some elements as well as popping some elements out of that container. We have our first default constructor here, stack array, and this default constructor is just calling another constructor, which is this one here, and this other constructor is the one which is doing the actual construction of our object. So we want to check if the n here is greater than 0. If we are creating this one with any number greater than 0, it can be 1, 2, 3, whatsoever, then we are going to use that n as our capacity. So when we are creating our object, we can send a value that we want to put as a maximum number of elements that this stack can contain. So if we put, for example, 20 when we are creating our object of stack, then that 20 is going to be used as a capacity. But if you enter any number which is negative, then our capacity is going to be using 10 instead. Okay, and here we are actually creating now our array of n elements. So we have created our array of n elements, maybe of 10 elements, which would be 10 spaces to stack or to put our elements of a stack. Okay, so the moment we have just created our object, or our elements or our stack object, which is our case is an array, we make an assumption that the size is 0 because we haven't inserted any element yet. It's just a container of 10 elements or n elements, but we haven't yet started putting elements in it. So our size is defaulted to 0. Okay, so we have the push. The push method is just accepting a number which is an integer, and it is first of all checking if the size is less than capacity. So if we make an assumption that our capacity is 10, from here, maybe our capacity is 10, then our size is 0. So the first time this one is executed, this statement will be true because the size will be 0 and capacity will be 10. And with that, then we are going to take the element and set that element on the first position. And we are going to increment the number of size, or the size, from 0 to 1. Now it is going to have one element added. So if we push 3 times, then our size is going to be 3, and we are going to have 3 elements on position 0, 1, and 2. Okay, while the part of pop is just to delete the last element and of course retain the value to the caller or the user of the method. So first of all, we are making a check. If the size is 0, then we don't need to delete because there are no elements remaining. So if this one is called and size is 0, we just want it to throw an exception. But otherwise, if the size is 1 and above, then it should retain the element on that position -1. So it's going to retain the element. If the size is 1, it's going to retain the element on index 0. If the size is 10, then it's going to retain the element on index 9. Like that. So here we are casting that result into integer. So here we are casting, because these elements, they are using the data type object. So we needed to explicitly cast it to integer as our return type for this. Okay, then this one just checks whether our stack is full, and this one just checks if our stack is actually empty. Okay, you could as well just use one method, maybe is full to do both, but we've just used 2 here for simplicity purposes, just to make sure that we are not distracted by the methods, but the functionality of our stack interface and classes. Okay, so that's what we have. These are 2 classes, a class and an interface that we have. In the main method, we are actually just creating an object of stack array using 4 as our capacity, and here we are pushing 4 elements. We have pushed 4 elements, so we have actually made it to be full by this point. So the first statement is just checking, is it full? If you push 3 elements and here you had 4, then this would have produced false, but in our case this should produce true, as we can see from this section below. And the next 4 are just pop statements. They are there just to remove the element. So the first element to be removed will be the last element that was inserted, then this, then this, then that. If we pop 4 times, then this last statement here is going to show empty true. So this is what we have. Okay, so what we want to achieve is to change this into something that will be generic in nature. We are going to change the stack interface to be generic, the stack array to be generic class, so that we can use the same class to come up with stacks of different data types. As we can see here, our stack that we are creating is we are only using the integers here, but we want something that we can use maybe integers, maybe double, maybe other objects, maybe strings, etc., using the same class. So in our next video, we're going to demonstrate how we can change this program to the stack and the stack interface and stack classes to actually be generic. Thank you.